Okay, so on your paper, whoops. Remember in Desmos, kids, you know you can just type in what 3 letters to get a definite integral? INT, all right? So go to graphing calculator. Okay, what's the lower limit on that? Was it 0?
Yes.
And then example 1, what was the upper limit? 4?
Yep.
Okay, read the function to me.
2x squared
2x to the second
plus 3x
plus 3x
minus 2.
minus 2. Remember what I have to put at the end of this to give me a value? Okay, so it looks like 58 2/3 is the actual integral. Do you guys agree with that? Okay, so the total area underneath is I could find the antiderivative. If I wanted to find the antiderivative, find the difference between my upper value and my lower value, I could. Okay, so it looks like the actual value, turn this into a fraction, looks like to be 176/3 or 58 2/3. Oh, where's my marker? So let's go do that. Let's on our notes say, okay. All right. So right up here, I'm going to type this in, or write this in, I should say. We are going to go by Desmos. What do we say the actual value was? 58.6 repeating? I should have picked a better one. This will work. Can I go 58? Yeah, let's go 58.6, okay? Like that. Fair deal? We all understand that's 2/3, right? 58 2/3. Okay. All right, so here's the deal. I can make you do all of these for 2 intervals and 4 intervals. Just a quick review. What's the total interval length on our definite interval, kids? If I had 2 intervals right here, how long would each interval be? 2 for n equals 2. How long would each interval be here? 1. So here's the cool part. I'm not going to make you do that, okay? Found this yesterday. I was sitting around thinking, how can I make my kids maybe appreciate me a little more? And I said, I have an idea. You want to know what that idea is? What if we went to Mr. Parsons' website and we went down here and we saw these online resources and calculators? See those there? See this little approximation calculator link right here, guys?
Yes.
You might want to write that down at the top of your notes so you know which one, but it'll be at the very top here. It's the newest one I put in. Approximation calculator. It's called the Riemann sum calculator. I kind of like this, although I haven't used it yet, so we're going to be in for a treat. Maybe it doesn't work, okay? And hopefully the ads are appropriate that pop up. Okay, guys, what was the original function? You said it was 2x to the... Notice how I type in an exponent. You got to lose the little caret key, which is like shift 6. 2x squared, was it plus 3x minus 2? Okay, you got that in there? Okay, now, was there a lower limit to our definite integral, kids? 0. What was the upper limit? Okay, now we're on n equals 2, aren't we? Okay, so how many intervals to start for that first column in our notes? 2. All right, let's do a left-hand sum right here, kiddos. I'm going to hit calculate. And what do they give me for an answer right down here? 20. I've got to double check and make sure that's right. So I would have been at 0 and 2. So 0 would have been negative 2. 2 would have been 8 plus 6 is 14, 12. So plus 12 times negative, or times 2. Let's see, that would have been 10 times 2, right? So what's this give me for a value here as an approximation? 20, okay? So here's what I want to do, kids. You all, this is pretty cool. We have a left-hand value of 20. Let's just go ahead and do all these. So is anybody by chance into that calculator? Okay. So what I might do is go back. Are you guys okay with this then?
Sure.
Kind of like it, or do you want to do it by hand?
No, I like this.
All right, so let's go back up here and change. Let's go instead of left hand, let's go to what next? Right hand and calculate. I wish it would put the answer right up here. I might look for a different one that's a little bit more user-friendly instead of having to scroll all the way down here, but what do they get for about a a right-hand sum about? 108, right? Okay. All right, so I was wondering if you guys would help me out with this. I'll leave this sheet up here. Would anybody happen to do the trapezoid for me? Trapezoid should be pretty easy, right? Should just be the average of these two, wouldn't it? You guys double check. I'll do the average in my head, 120. I get 64. See if trapezoid kicks out 64 on that calculator. Is it 64?
Yeah.
64? Okay. Now, my question here is this. Is anybody willing to type in the midpoint rule for me?
Why is it being so slow? No,
Is it 56?
for the midpoint,
For the midpoint, is it 56?
it is loading.
Okay, I'll make sure here. I'm pretty sure it's 56, but I could be wrong.
Oh yeah, it's 56.
It is 56. Okay. Gosh, good thing I did my homework. Okay, now, there's this new idea up here today about Simpson's rule. Okay? Simpson's rule is pretty nifty, all right? If you take a look at the top of your notes, kids, Simpson's rule, to find an approximation for that, what two pieces of information must you have in order to make Simpson's rule work? Take a look at the formula in your vocabulary.
The midpoint and the trapezoid.
You've got to know a midpoint value, and you've got to know a trapezoid value. Do I know a midpoint value and a trapezoid value at this point? Good morning. Do I know those values?
Yep.
Okay, so it says take two of the what there, kids?
Two midpoint.
Okay, so this new rule for approximations, and let me tell you why this is so important today. Oh, now my computer is slow. See what you did, Tanny?
I'm so sorry.
Oh, that's what's the blame? We're trying to find we're playing the blame game today, aren't we, guys?
We really are.
We're good at it. Okay. All right, so talk to me. How many midpoints do we need, kids? One or two by rule? Two of them. So we're going to go 2 times, what was our midpoint approximation for two intervals on this definite integral?
56.
2 times 56. What do we got for a value there?
112.
What do I need to add in, friends?
64.
Which is my trapezoid value, right?
Yep. And then divide all that by 3.
And divide all this by 3. Now, I want you to notice something right here. Simpson's rule is pretty powerful. Take a look at your value up there on the calculator. What does it say?
58.6.
How many intervals did we actually use here, technically? 2 intervals, right? I have a question for you. We've talked about left and right-hand sums, and we've said in the past, if I have more and more intervals, what's true about our approximation compared to an actual definite interval?
It's closer.
It's much more accurate. But all of a sudden here, kids, we're only taking how many intervals right here? 2. I come up here, what's this value for Simpson's rule?
58.6 repeating.
Quick question for you. How does this, oh, where are my tools? How does this, right here, no, I don't want to highlight blue with blue. That would make no sense. Okay, I want to accentuate my art. There it is. How does this compare to the actual, friends?
It's the same.
Wait a minute. You said the more intervals I take, the more accurate something gets, right?
Yep.
But I've just shown you here that do we necessarily have to have a ton of intervals to get a really accurate estimate?
Nope.
In fact, how many intervals do I have here?
2.
We use 2 intervals under this new rule that all of a sudden, compared to my actual interval, we already have what? Okay. Now, is this going to happen every single time? You want to know what the answer to that is?
No.
No. Have a good day. Okay? No, it's not going to happen that way. But that's pretty cool right there to know that I can actually find the definite interval and be really close to it with just how many intervals? 2. Now, here's what I want to talk about. This is where things get interesting. We're going to talk about this idea of error, and I'm going to show you some more interesting stuff about this, but we're gonna confirm what we know. But guys, here's the deal. If the left-hand sum was 20 right here, what would the error of this be? Understanding the error is equal to an actual, oops. Understanding the error is an actual minus a what? All right? Well, guys, what is the actual, kids? 58.6 repeating, okay? What's my left-hand sum approximation?
20.
So how far off are we? Wouldn't that be 38.6?
Oh, yes.
The left-hand sum has an error of 38.6. Okay? Guys, do me a favor here. Take the right away from 58.6 repeating. Tell me what you have. So you're going to go 58.6 repeating minus
I have negative 49.4.
negative 49 point. Okay, and I'm actually going to call it negative 49 point. It's probably going to be 3 repeating, I think.
Yeah.
Okay. All right. Who wants to do the 64 for me?
I got it.
Okay. Who wants to take the actual 58.6 repeating minus 64? I need someone to do the midpoint for me. Well, I can do that. That's just 2.6 repeating, isn't it? Okay. What's the error on Simpson going to be already? 0. When we get 0 error, that's a good thing, isn't it?
Yeah.
Okay. Anybody got the trapezoid for me? Is it negative 5.3 repeating?
Yeah.
Quick question. What's the least accurate up there?
The right-hand sum.
The left and right hand sums are least accurate, right?
Yeah.
Okay, what's the most accurate up there? Simpson's rule. Now guys, one would think that if I go ahead and have more intervals, what should actually happen to the amount of error? Should the errors get bigger or become smaller? They should become smaller. We're going to do the same thing for how many intervals now? 4. So I'm going to jump back into this calculator right here. It's pretty nifty. So right here, back in this calculator, I've got to go back up. Same integral, lower limit 0 to 4, but how many intervals this time, kids? 4. All right. What are we really doing to the number of, how do I want to say this? What are we really doing to the number of intervals? It went from 2 to 4, so by what factor are we increasing? 2 times what would make 4?
2.
So we're really doubling the number of intervals here, aren't we? Want to make some connections here, so pay attention to this. Left-hand sum, I get about 38. Okay, so on the left-hand sum, write these down. 38. I'll calculate them up here. You write them down. I'll do the right-hand sum now. So what did you write down? Left-hand sum. Okay. Right-hand sum. Calculate. I've got. Okay, write down 82 for right-hand sum. Okay, what's next list? Is it trapezoid or midpoint for you? Trapezoid?
Yeah.
Okay, trapezoid, I get about 60. Okay, you guys got 60 down for trapezoid? Okay, we need to do midpoint and what else? Oh, I didn't want that. Midpoint rule, I come up with 58. Okay, so by our calculator now, which is pretty nifty, I think, help me, run me down this column. First one was 38, I think, right?
38, 82, 60, 58.
82, 60, 58. Okay, so we would take 2 times the midpoints. Trapezoid, I'll just tell you right here, if you're at 0 for error already, can there be any more error? Or any less error, I should say? This is going to be 58.6 again when you do that. Okay? Alright, let's talk. Kids, this is what I want to show you. Alright? And we'll talk more about this as we consider what's happening here. But in this problem right here, I have 38 as my error for how, or as my approximation for how many intervals? 4. So my left-hand sum of 4 intervals is 38. When I had a left-hand sum of 2 intervals, we had 20, right?
Yep.
Which led to an error of how much?
38.6.
Okay. How are you going to find your error of 4 intervals now?
58.6 minus 38.
So here's the deal. You're going to have this as 20 point.
6
Okay. Help me find the errors for all 4 here. What's the error of the last one going to be, obviously?
0.
0. This is going to be about 0.6 repeating. I can see that one easily. So the one I'm maybe struggling with is 58.6 repeating minus 82. Does somebody want to do that for me?
It's 82.
Yep.
23.3 repeat.
23.3 repeating?
Yeah,
Negative 23.3 repeating, thank you. How about for the trapezoid rule there then? So 58.6 repeating minus 60. I think that should be negative 1.3 repeating, isn't it?
Yep.
Okay, so here's what I want to do, kids. We're going to talk about this idea of ratio of error a lot, okay? You told me that when I went from 2 intervals to 4 intervals, we multiplied that first interval set by what value to get to 4? We doubled, right? Okay, so what I'm going to do, I'm just going to write a 2 up here, okay? Okay, that 2 is going to represent going from 2 intervals to 4 intervals, okay? In other words, the factor that we're by, or the multiple we're increasing by is times 2, okay? All right, here's what we're going to start looking at, the ratio of errors. What we're going to do is we're going to take the error 2's and divide them by the error 4's, and I want to talk about what's really going on here, okay? We're going to take all of our error 2 values and we're going to divide it by the error 4 values. Now, Simpson's rule, I'm going to pretty much have to tell you that because in Simpson's rule, we're going to have 0 divided by what?
0.
0 divided by 0, that's considered an indeterminate. We can't do that, all right? But I will talk to you about a rule here, but I will kind of talk to you about this. Somebody take that 38.6 repeating, put like 5 or 6 sixes in there, and divide it by 20.6 repeating for error 2 divided by error 4 for left-hand values.
1.87096.
Okay, so let's just go about 3 places. So about 1.871.
871. Yeah.
So we get approximately 1.871. Okay, do that for the right-hand values that were errors. So negative 49.3 repeating, and divide that by negative 23.3 repeating.
Yeah, 2.114.
Okay, here's the deal. I'm going to kind of jump ahead right here, but here's the deal. If you would look at these 2 error values right here and average them out, go ahead and average those 2 values. 1.8711 plus 2.114, divide that by 2. Tell me what you got.
1.9.
So pretty darn close to what whole value?
2.
Okay? All right, listen carefully on this. For rules of left and right hand sums, in this case, we took the number of intervals that we started with to the number of intervals that we ended with and doubled them, right? Okay, think about this. When I doubled this right here, the error ratio going from 2 to 4 gets cut almost by a factor of what almost? What did this become almost?
2.
Okay, what this is kind of saying is this. As I double the number of intervals, the error, when I looked at 2 intervals of error and 4 intervals of error, the error pretty much got cut by a factor of 2, or got cut in almost half. Think about this, 38.6 repeating. Half of that's 19.3 repeating. But isn't 19.3 pretty close to this? What's half of 49.3? Well, kids, it's 24.6. Is 24.6 pretty close to that? So the general rule for left and right hand sums is this. If I double the number of intervals, the error pretty much gets cut. Not exactly in half, but pretty close to it. What if I did this? What if I quadrupled the number of intervals? Then the error would probably get cut by pretty close to what? So divide by 4, okay? All right, so these two right here are really going to get cut by a factor of pretty much 2 to the first power, okay? Now, let's see if the same holds true for trapezoid midpoint rule. Okay, what do we think is more accurate, left and right or trapezoid and midpoint? Well, we'll find out, I guess.
I'm gonna go trapezoid.
Okay, take trapezoid rules and divide them. Take negative 5.3 repeating and divide by negative 1.3 repeating and tell me what you get approximately. We'll go 3 places.
We got 3.9 repeating.
So 3.9 repeating. So can I call it 3.999? All right. Take that 2.6 repeating and divide it by 0.6 repeating. I'm going to get a quick cup of water.
Yeah, 3.999.
Oh. Again, 3.999. What's 3.999 really close to? 4. Which would be like 2 to what power? Okay, so here's the deal. This is here pretty much 4, isn't it? So the error, when you double the number of intervals under midpoint rule and trapezoid rule, the error, instead of getting cut in half, actually got cut by a factor of what? 4. It's like if I would go here and divide by 4. Trapezoid rule and midpoint rule, whatever your factor is by multiplying. In this case, what are we multiplying our interval of 2 to get to 4 by? 2. Okay? This is kind of like saying, well, my error then will change by a factor of 2 to the second power. So here's the deal. Listen carefully. Under midpoint rule and trapezoid rule, all right, I have an error for 3 intervals of 81. Okay, so 3 intervals. What's my error? What did I just tell you the error was? 81.
81.
Okay, here's the deal. I'm going to go from 3 intervals to 9 intervals. So what factor am I jumping up by? 3 to 9. Jumping up by 3. What was my error for 3 intervals?
81.
So what's the error for 9 intervals going to be? Well, it would be not divisible by 3, but it would be divisible by 3 to the second power under, because remember, 2 to what power would make this factor of 4 over here? 2 to the what?
A second.
Okay. So what would 3 to the second get you? Because I went from 3 intervals up to 9. It's like multiplying by 3, right?
Huh.
So what is 3 to the second?
9.
9. So that error of 81 will get cut by a factor of, so what's 81 divided by 9?
9.
So the error for 9 intervals would be 9. Okay, we'll look at more examples here, okay? All right, now, this one here I can't really do anything because the error is already what, kids?
0.
But if there was some error under Simpson's rule, then the error would get cut by about 2 to the 4th power. You would actually, Simpson's rule turns out to be 16 times better, or I shouldn't say 16 times better. Turns out to be 10 to the 4th times better than left and right hand sums, okay? All right, so let's look at some more here. Okay, do you have the numbers down here?
Yes.
Let's go to the second page. Oh, no breaks today. Oh, no. Okay, consider this. We're going to go with this, all right? Ooh. All right, we're going to find the actual function here, okay? So here's what I need help with, guys. Who wants to be my error 2 column in the calculator? Anybody want to do that?
Sure.
Okay, so let's just do one together. We'll figure this out, okay? What function are we worried about here, kids?
1 over x.
Okay, so the only way I can find error is if I know the actual value. Do you guys agree with that?
Yeah.
All right, so let's look at this.
Big numbers.
So I'm going to go to decimals. And I'm going to put in the integral. Clean this out. So we're going to go to the integral of.
It's a lot of numbers.
Okay, is it 1 to 2 for my function?
Yep.
1 over x, right? Okay, let's go. I'm going to go 5 places on this thing. Okay, I'm going to go 5 places on this thing. So 693, remember, 69315. Okay, so I'm going to write right up here by decimals. We know that the actual for this is, what did I say, 0.69315?
Yep.
The actual value for this is 0.69315. And even at that, that's still an approximation, because did I get all the decimals in there?
Nope.
Nope. Okay. All right. We need to do error 2, error 10, error 50, error 250. Oh, Lordy. Okay. I'm going to do this quickly. I'm going to go back to this other calculator. Okay, what's our function again, kids? 1 over x, is that right?
Yeah.
Okay, what's my lower limit? 1? 2? First one is 2 intervals, is that right? Because we're doing error of 2. Okay. I'm going to do the left-hand sum right here. We're going to go how many places on decimals, kids? 5 places. Okay, what do I get for an approximation down here? What do I get for an approximation? 0.6 repeating. Okay, so in my chart right here, I want to take the actual, which is what value again?
0.69315.
Okay, so let me get my calculator open again. 0.69. Whoops. Minus. Was it 0.6 repeating?
Yep.
I'll go 5 of them, okay, because we're going to go 5 places. Okay, what's the error there, kids?
0.02649.
0.02649. Write that down in error 2 for your left-hand value. Okay. Guys have that? Okay, I'm going to go to right-hand sum. Okay. Whoops. Good, 0.583 repeating, is that right? Okay, something doesn't seem right here. Do I have the limits in right on this, kids? 1 to 2, 2 intervals. Huh. I gotta check something again. Hang on a second. I didn't like the way that this is working out. Did I have left hand in there the first time? Nope. Should have been point what?
8.
Okay, so I need to type that in again. 0.69315 minus 0.8. 1, 2, 3, 4. That's what that first error should be. Negative. Write that down there. Error for left 2. That was my mistake, guys. Negative 0.14018. Now, are we pretty close to the actual right there? If that's the error, is that a good error?
Yeah.
Yeah. Okay. All right, let's do the right then. The right turned out to be 0.583 if I remember correctly. So I'm going to go 0.695. Darn it. Okay, here is your left error. Okay, there's your left error too. 0.10982. 0.10982. Okay, you guys have that?
Yep.
Okay, let me go up here for trapezoid rule. Point 70833. So I'm going to go point. What's my number? 69315. What's the error there? 0.70833.
Yeah.
Okay, there's that for the trapezoid. Good with that?
Yep.
Now we're just going to do 2, and then I'm going to give you the other values real quickly, all right? And what do we got to do? Midpoint yet? And Simpson? Okay, I'm going to go 0.69 minus okay, there's the midpoint error. 0.00744. Okay, do you understand how I'm getting all these errors? That's my first question.
Yep.
Now, I'm not going to be redundant with this right here, but I'm going to get the rest of these errors to you here real quickly. Okay, we'll get this table filled in, and we're going to pick this up tomorrow, okay?
Sounds like a good plan to me.
You think so?
Yeah. Tomorrow's Wednesday, right?
Yes, sir. Okay, so I need help from you guys. I need help from you guys right here. I don't want to go shopping right now. Okay, help me with the errors right here. What was the left-hand one?
-.14018.
Okay, what was the right error?
0.10982.
What was my trapezoid error?
-.01518.
Negative
Yeah,
0.01518.
yep,
What was the midpoint error?
0.00744.
Okay, and then the error that I'm gonna have in, okay, look at the error in this one. Okay, it is negative point. I gotta count here, 1, 2, 3. This one will go a little further, okay? 106 7877. Okay. All right, so I'm gonna give you some more errors, okay? You ready for errors?
Yeah.
I'm only gonna go 3 places in the rest of these, okay? Or 4 places. The error for this one here should be negative 0.0256. This should be 0.0244. And again, you understand, I would have changed that calculator to how many intervals now, guys?
10.
I would have taken this actual minus whatever these were kicking out for values and to get them, right? Okay, so I won't waste your time with that, but I want these numbers in here to make another point here, so I'll show you what we're trying to accomplish here. Let's see, the midpoint rule, ratio of errors for, the errors for 10 of trapezoid rule is next, right? Negative 0.00062. The midpoint error is 0.00031. Now, is that a lot of error, kids, or not?
Very little.
Very little, isn't it? And the error in Simpson is negative point. Looks like 1, 2, 3, 6 zeros and a 1940. Okay,
Wait, how many zeros is that?
6 of them. Okay. And I think I only really need to go up to about 50 on this. I don't think I'm going to do the error for 250. I think that what we have here will be enough. So the error for 50 for left, negative 0.0050. The right is 0.0050. The error for 50 in terms of midpoint and trapezoid rule is 4 zeros, a negative decimal point, 4 zeros. And then the midpoint is decimal point followed by 4 zeros. And then Simpson's rule, holy smokes.
I think we get the point with that one.
It's 9 zeros, so it's going to be negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, followed by a 3. Okay. So let's make sure we have that filled in up to that point, and then we are going to look at some of those values in terms of what we're doing with them and how to talk about errors. Here's the deal. Once you figure out the pattern of how errors work, you're not going to have to be filling in values like that all the time. Okay? You guys cool with that?
Oh, yeah.
Yes, sir.
Do you have your numbers?
Yep.
Let me stop this.